Imagine this situation. You are a forensics expert, working in a typically peaceful neighborhood in Tennessee. Then, one fine day, 3 people are murdered within hours of each other in Chattanooga. The police department conducting the investigation is not sure whether these are isolated homicides or the work of a potential serial killer. Meanwhile, you come across a research article published in Science Advances, which clearly states that AI can now determine whether fingerprints made by different digits belong to the same person or to various unrelated suspects with a high degree of confidence. What would you do in such a situation? Well, if you're smart, you'd definitely consider consulting Columbia University's AI researchers to gain further insights into the triple homicide in Chattanooga, Tennessee, wouldn't you? But before we proceed any further, let me tell you that such a neural network-based program now exists in reality. So, as a forensics expert, if you have obtained fingerprints of the right index finger from crime scene A, left middle finger from crime scene B, and right thumb from crime scene C, then Columbia University's AI program can tell you with a high degree of confidence whether or not these fingerprints belong to the same person or to different persons. To achieve this, the research team initially trained their AI-based program using nearly 500,000 synthetic images of fingerprints. Subsequently, the program underwent training on over 53,000 fingerprints, obtained from more than 900 individuals. The results were quite encouraging. The trained system was able to correctly identify 2 fingerprints belonging to the same person 77% of the time, a rate significantly higher than the 50% expected by random chance. According to the research team, cross-finger similarity can be explained, almost exclusively, by the binary ridge patterns. Moreover, ridge orientation explains a majority of the cross-finger similarity. Quite notably, the usefulness of this novel AI-based discovery seems legitimate, considering the fact that cross-finger similarity can reduce the work in criminal justice investigations by more than an order of magnitude. So, why is this paper creating waves in the field of AI-based forensics? Well, that's because it's presumably the first study showing that different digits belonging to the same person tend to exhibit identifiable similarities. Of course, the study has certain limitations and cannot be used right away by forensics experts. For instance, demographic fairness experiments reveal the risk of certain demographic groups being falsely investigated more often than others. Additionally, the AI-based program needs extensive training on large government databases. Also, the idea that prints from different fingers of the same person share strong similarities is not entirely new. Despite these obvious limitations, this new finding almost certainly paves the way for further advancements in the field of AI-based forensic fingerprint analysis. Subscribe to SciTech Vault for more such videos.